to a new video, and today we are going to solve the JEE Advanced sample paper that has been released by Iit Kanpur, just like the last year when I was also a JEE aspirant. And now I'm so lucky that my institute Iit Kanpur is organizing this year's JEE Advanced 2025, and that, as usual, they have released the sample paper. So let us try and solve this sample paper. And today I will be solving the physics paper, and I will be posting videos section wise, like see, as you can see, this is the first section which has single correct type options. Similarly, I will post the next video in the next about the next section. I think there are 4 sections in this paper, covering 18 questions in the physics part, and so I will be posting 4 videos for the physics part solution. And then if I get time, as you know, JEE Advanced 2025 is now near, it's on 18th of May. So if I get time to post any other videos, I will do for the chemistry or the mathematics part as well. So let us do it for the physics part before that. So now let us start with the first section, which has the instruction of having only single correct options for each and every question, and the marking scheme is +3 -1, as you all know, and for not attempting it's 0. Okay, so the first question, it says a spherical water drop, when deformed slightly, oscillates about its equilibrium shape. The frequency of this oscillation f can be described by its mass m, radius r, and a third variable is x, where x is either the universal gravitational constant g or the surface tension s. Using the appropriate variable f can be expressed as, this is the expression that has been given for f, and it has been said that k is a dimensionless constant. Okay, so we have to choose from here which is correct option. So okay, let us first try and understand what is x, because there are 2 possibilities for x. Either x can be gravitational constant g, or it can be surface tension s. Now for this, we understand what is happening in this question. We have a spherical water drop. Let's say the mean radius was capital R0. Now if it is slightly deformed about its center, which is like this O, let us say the deformation is like something like this. We all know that this water droplet exists in the air, so there are 2 surfaces basically. There's the air surface. This surface of contact has 2 surfaces basically, the air surface and the water which is inside the drop. So this surface right here has a surface tension which is T, let's say, and also this surface has a surface tension T, right? Since at equilibrium shape it is spherical, though T I can say is minimum, because at the spherical shape the surface energy is minimized. So equilibrium shape of any object is that shape which it tries to attain to minimize its surface energy, because that's the most stable state of existence of any object. So for oscillation, like if I deform it, so obviously the restoring force that will be provided to bring this drop to its equilibrium, back to its equilibrium shape, will be surface tension, and there is no action of G here whatsoever. So G is nowhere. So we understand that it is surface tension, which is or T. So x is basically T, and the dimension of x then will be dimension of surface tension, which is force per unit length. So it is ml t power -2 minus l by l, so it is m t power -2, right? And now if I check the dimensions of frequency, that is T inverse, and from the above equation it should be equal to m power alpha, r power beta, and x power gamma, as k is a dimensionless constant. So if I equate this, it is m power alpha dot l power beta dot m power gamma t power -2 gamma. Further solving this equation, we get this, which is equal to t power -1. Now by comparison, you can easily see that alpha plus gamma equal to 0, beta equal to 0, and -2 gamma equal to -1. So from here I can say alpha equal to -half, beta equal to 0, and gamma equal to half. I think you can all see that. So according to this, which is the correct option? Let us see. The first option says alpha equal to minus half, okay, beta equal to 0, alright, gamma equal to half. Oh, nice. So the first option is only correct here. So the answer to this question is option A. Okay, now let's move on to the next question. It was quite easy. According to JEE Advanced level, it's quite easy. The first question at least. Okay, so now this in the second question, it says an unpolarized monochromatic beam of light is incident on a planar interface of two media of refractive index n1 and n2 respectively, and at an angle of incidence I, it is found that the reflected beam is completely polarized. Okay, so it's completely polarized. It's a very important statement right here. So let us first understand the concept about behind this, what is happening actually. So when I'm talking about unpolarized light, we all know that when this light is coming from this when it is incident from this medium, the first medium, it's unpolarized, alright, it's oscillating in all possible directions, so it's unpolarized light. Now when it comes to this surface, it hits this surface where the medium is changing basically, then two things happen. One obviously is the reflected ray that is coming, and also, which is not being shown in the diagram, it's the transmitted ray which will go from here to here. Now the angle would obviously depend on whether the medium to which it is going is denser or rarer. That is a different story, but there would be a transmitted ray, alright. So now the theory says, or from the law of polarization, we know that the transmitted ray is partially polarized in the plane of incidence. I mean, this plane, you can see the page. In that page, it will be partially polarized in this direction. Partially polarized, it means that there would be some also into the plane or somewhere else in some other direction. So it will be partially polarized, and the refracted ray would be partially polarized as well in the direction perpendicular to the plane of incidence. So it will be in this direction, and since it's partially polarized, it will be in some other direction as well. But from the Brewster law, we know that this reflected ray can be 100% polarized, or completely polarized if and only if this angle is 90 degree, which means the angle between reflected ray and transmitted ray is 90 degree. Alright, so the reflected ray and the transmitted ray is perpendicular to each other. As I said, this is the transmitted, this is reflected, and this is incident. So this is the thing, this is the concept. So we have this as 90. So now just we need to look for geometry, and this is now a question of geometry. See, so this is I, this is R. We know by law of reflection, it is I equal to R, and if this is R, this has to be 90 minus R, because since it is completely polarized, this will be 90, this angle is 90, so this is 90 minus R, or which is equal to 90 minus I. So by Snell's law, we have Ni into sin I equal to N2 into sin 90 minus I, because this is the refracted ray, so refracted or transmitted ray, as whatever you like to call it. Sin I equal to N2 cos I, therefore tan I equal to N2 by Ni, or since it is N2 by Ni, now I equal to tan inverse N2 by Ni, right? So this is one thing that we have obtained. So it is N2 by Ni. Now what we can do, okay, since I have told you all the concept about this, anywhere did you see that there was any relevance of how what was the relation between the refractive index of the two medium? Nowhere. So we don't care whether the ray is going from rarer to denser to rarer. We doesn't care. we don't care basically. So whatever relation that we obtain is only about the angle of incidence in terms of the refractive index of the two medium. So the relation which is given as ni has to be greater than n2, or n1 has to be greater than n2, or n2 has to be greater than n1, all these are not necessary. Anything can happen, we don't know. So according to this, the correct option must be D. Alright, so this is our second question as well. This is also very easy, very theoretical question. So let's move on to the next question. Okay, now this question looks big, and it's basically based on thermodynamics. So let us see what this question says. 1 mole of an ideal monoatomic gas, okay, so it's a monoatomic gas, undergoes ideal monoatomic gas undergoes a thermodynamic PV cycle, alright, given below, where processes 2 to 3 and 4 to 1 are isothermal. Okay, we can see at constant temperatures T0 and 1 plus beta T0. Okay, which one of the following statements is false? Very important. Okay, false. So it has been given at N2 0.7. Okay, so let us just from the option, let us look what things we need to find out at the general view. Okay, the first option asks us about the efficiency of the cycle. Okay, we need to find efficiency. Then we have to find ratio of heat transfer in 2 to 3 and 1 to 2. Okay, and then we have to find net work done as well in this thermodynamic cycle, and we need to find in this particular condition, if beta is much less than ln alpha, what would be the efficiency. Okay, so at gross we need to find three things as far as I understand. The first thing is efficiency, the second thing is net work done in this cycle, and third thing is heat ratio of heat transfer, which is from Q1 to 2. Okay, so now we also know if we have to find efficiency, we need to find net work done, and so this would be equivalent. If we find this two, it will be alright. And so okay, to solve this question, let us go proceed step by step. We address each and every step of this thermodynamic cycle, and just let us break it down. All the heat transfer, work done, let us write everything. Then once everything would be solved. Okay, so the first law of thermodynamics states Q equal to del U plus W. Alright, so in the first process 1 to 2, what is the work done? It is P0. Okay, so first let us write something more. Okay, let us look for the states, the condition of the states. The state 1, the temperature is just a minute. Yeah, state 1, the temperature is T0. State 2, the temperature is 1 plus beta T0. Since at constant pressure P0 the temperature is increasing from T0 to 1 plus beta T0, we also know the volume also would increase same proportionately. So it is 1 plus beta V0, which was initially V0 at this state, because at constant P, V is directly proportional to T, right? Now since it is 1 plus beta T0 temperature, and since it is a high isothermal process, this is also 1 plus beta T0. So at constant temperature, pressure is going from P0 to P0 by alpha. So we know P is proportional to 1 by V at constant T, right? This is at constant P. At constant P, this is a constant T. So according to the rule, I can say that P0 into 1 plus beta V0 equal to P0 by alpha times V. So easily I can notice that this is nothing but from this state. Okay, so this is nothing but alpha times 1 plus beta into V0, and since this is going from here to here again at constant pressure, and the temperature again here is T0, so we are reducing by a factor of 1 plus beta, so the volume here would be alpha V0. Okay, so we now have all the parameters and state parameters that we need. So let us now focus into this first step, which is 1 to 2. What is happening? So here, since temperature is changed, like since it is happening at constant pressure, it's isobaric. So the work done would be P naught delta V, right? And delta V here is beta V naught. So it is beta P naught V naught. Work done in the first stage, first step from 1 to 2. It is beta P naught V naught. Similarly, we can write Q 1 to 2, which is basically del U plus W. Now since temperature is also changing, so we can write del U as NCV del T. So, and it is 1 mole. It has been given it is 1 mole of the gas is reacting here. Easily you can see that. So importantly, this is CV del T. So CV del T is, and CV for monoatomic gas is 3R by 2, and here del T is 1 plus beta T naught minus T naught. So it is beta T naught. So it is 3R by 2 into beta T naught, and W we already have, it is beta P naught V naught. Okay, one thing, since the state is P naught, the temperature is T naught and it is V naught, we can easily say that P naught V naught is equal to RT naught. This is one thing. So we can club this RT naught into, and we can write is 3 beta by 2 P naught V naught. So if I add this 3 beta by 2 plus beta P naught V naught, and from the first step we get 5 beta by 2 P naught V naught, right? So this is the first the heat change that we get here. Now let us focus on the next step, which is 2 to 3, and it is an isothermal process. As mentioned above, it is an isothermal process right here, happening at 1 plus beta T naught temperature. So since it's isothermal, the internal energy change would be 0. So Q would be equal to W, and W we all know the relation between W, it is nRT, the temperature at which it is happening, and ln we can write Vf by Vi, the work done. Now it is 1 mole, number of moles is 1 R, and the temperature is 1 plus beta T naught, and it is ln Vf by V. So Vf is, we see it is alpha 1 plus beta V naught, and Vi is alpha V naught. So it is 1 plus beta. Alright, so this is my and we know RT naught is P naught V naught. So it is, I can easily write this as ln 1 plus beta ln 1 plus beta P naught V naught. This is my heat transfer and work done for the second to third step. Now for third to fourth, we have again isobaric process. So we have W equal to, at constant pressure, which was P naught by alpha. If you remember from the very first step pressure, it's P naught by alpha, and the volume is decreasing, so it is minus P naught by alpha, and the decrease in the volume is from alpha 1 plus beta into V naught to alpha V naught. So the change is alpha beta into V naught. So the change is alpha beta into V naught, which is again beta P naught V naught, but with a minus sign. Sorry, yeah. So minus P naught V naught into beta, right? Sorry, again. Yeah, minus beta P naught V naught. And similarly, I can write delta U in this step as NCV del T, and del T is again, del T is also negative because the temperature is reducing. Del T is negative, so it is minus beta T naught, and NCV del T, so it is 3R by 2 del T is minus beta T naught, and RT naught is PV, so minus 3 beta by 2 P naught V naught. This is my value. So work done in this step is nothing but minus beta plus 3 beta by 2 P naught V naught, which is minus 5 beta by 2 P naught V naught. So just the opposite of the first step 1 to 2 that we have done. Now for moving to 4 to 1, the last process. It is again isothermal process, and del U is 0. So Q is again equal to W. So W is N0 T0. So N is 1 into R into the temperature here now is T0 in this cycle. So it is T0 ln Vf by Vi. So the final volume is V0 and the initial was alpha V0, right? So the final volume is okay, probably I've made a mistake here. In step 2 to 3, Vf by Vi, Vf was alpha 1 to 1 plus beta V0 and Vi was 1 plus beta into V0. So it is not 1 plus beta, it should be alpha. Sorry. So I have made a mistake, guys. Please change it. This is alpha, ln alpha. Yeah. So this is ln alpha. This is ln alpha here. P0 V0. Yeah. I hope you can understand. You can check the graph and you can solve it yourself. You will see that it would be wrong. So this is 1 by alpha. Similarly, you can see after dividing the final and initial volumes. So it is minus R T0 is again P0 V0. So minus ln alpha P0 V0. So this is my total stuff. So from here, 3 things you can find out. What is W net? Adding all the work done from each and every process. So the first work done, the first step was 5 beta by 2 P0 V0, which will be cancelled from here from the third to fourth step. So it will become 0. And okay, let me write each and every step. From 1 to 2, this was work done. From 2 to 3, the work done was 1 plus beta ln alpha P0 V0. Next, from 3 to 4, it was this, and from 4 to 1, it was this. So the net work done is basically beta ln alpha P0 V0. So the net work done is beta into ln alpha P0 V0. So as I remember the option C, it was given net work done is this, which is absolutely incorrect. As you can see, it is not right. Okay, so this is incorrect. So what we have is W net as beta ln alpha. Let me write it here as well because it is needed. P0 V0. Now let us write Q. We need Q1 to 2 by Q2 to 3 by Q1 to 2. Okay, so let us write Q2 to 3 by Q1 to 2, and let us see what both of them are. Right. So Q2 to 3 was this and Q1 to 2 was this. So if I divide both of them, ln alpha P0 V0, and it was 3 beta by 2 P0 V0, 3 beta by 2 P0 V0 mod value. So I would get something like 2 into 1 plus beta ln alpha by 3 beta. I think some values of alpha beta was given. Okay, so alpha was 2 and beta is 1 by 4. Okay, let me write the values. Alpha equal to 2, beta equal to 1 by 4. So if I plug this in, what would I get? It is 2 5 by 4 ln 2 by 3 by 4. So it is 10 by 3. ln 2 was given as 0.7 as far as I remember, and it is 7 by 3. Oh, okay, so I have made a very bad mistake here. It's 5 beta by 2 P0 V0. So Q is this one, right? So this is my Q12. It's not this, it is delta U. So okay, I have taken the wrong thing. So it would be 5 beta V by 2. So this is 5 only. So this is 5 by 4. It would cancel out and it would become 2 ln 2, which is 2 into 0.7. Yeah, so this is 1.4. Okay, So this option is right. This option is right. I have to mark false, right? So okay, our answer was on the first this statement only, but let us check for the other as well since we have done so much. Okay, so for eta we know for efficiency W net divided by Q accepted, right? So now Q accepted is whatever the system has accepted, which is Q1-2 and Q2-3, and other all steps it was rejected, so it would not be, this would also not be. So Q accepted is basically W net we had already had this one, so beta ln alpha P naught V naught. Now Q accepted was Q23 plus Q12, which is 1 plus beta ln alpha P naught V naught plus 5 beta by 2 P naught V naught. This is my efficiency, and if I plug in these values here, what should I get? I should get 1 by 4 ln 2 divided by 5 by 4 ln 2 plus 5 by 8 plus 5 by 8, right? So here I would get 2 into 0.7 10 into 0.7 plus 5, and if I simplify this, it would be 1.4 by 12, and this is approximately 0.12. You can find out. So this is also correct. The first option is also correct. Now for beta much less than ln alpha, we have already find the efficiency of this cycle in general terms. Now if beta is much than ln alpha, if I make this approximation, so just for this what I can do is I can actually, okay, P naught, we can cancel out all this P naught V naught from here, and just if I take ln alpha common from here, so my eta gets transformed into beta, just a minute, yeah, beta 1 plus beta plus 5 beta by 2 ln alpha, and as per my approximation this would actually become 0 according to this approximation. So whatever my my efficiency turns out to be, it will be beta by 1 plus beta. Alright, now for beta much less than like 1 plus for by ln alpha, our last option states that the cycle will approach the efficiency which that is of a Carnot cycle working between the maximum and minimum temperatures. And we know the Carnot cycle efficiency is the maximum cycle any ideal cycle can attain. So what is the efficiency of the Carnot cycle? Eta Carnot can be written as 1 minus T sink by T source, which is the lower temperature and the higher temperature. And obviously this is from, in this case it is T naught by 1 plus beta times T naught, and it is beta by 1 plus beta, which is the same as we obtain which we obtain here by that condition, which is beta much less than alpha. So the last option is also right. So the only option that is false is option C, and that is our answer for this question. Yeah. So now let us move to the last question for the first section, which is single correct. Here we can see that the question says, consider a one-dimensional box of size L which contains 4 electrons, each of mass me. Define E naught to be, E naught is the ground state energy, and okay, this is something given constant. Assume that the electrons are non-interacting, obey the Pauli exclusion principle, and described by standing de Broglie waves confined within the box. Okay, so now you are going to actually this question, this principle belongs to quantum physics, and this problem is called as 1D infinite well problem, and it is very popular for chemistry as well. The the applications of uh, quantum physics in chemistry, when you do structure of atom and all those things. So but here we don't need to know any kind of quantum physics or anything. We can just basically simply solve this question by the idea of standing de Broglie waves. And we know that in an orbit, in a Bohr orbit, why do we call it a stationary orbit? Because the waves that are actually generated by electrons in Bohr quantized orbits are basically standing waves, and that's why the energy in a Bohr orbit is always quantized, or it is due to some integer, or like the nth state, which is also known as the principal quantum number, in the orbit number in which the electrons are residing. And basically n for waves would actually, as you if you have the idea of wave mechanics, you know that n basically would represent the number of nodes in that standing wave which is being created. So by the same concept, let us try to solve this question. So we have a 1D box. Alright, we have a 1D box here, and in this box there is an electron which is basically forming standing waves, right? Yeah. So since it is forming standing waves, if the node was 0, let us say there was no node, then this would be the standing wave that will be formed. If there is one node, let's say if there was one node, then the standing wave which would have been formed would be something like this. Alright, with a node here at the center. So these are the waves that would be formed, and these are the different possible states of this electron residing in this 1D box. Alright, so how to solve this question? The very basic thing is, what are the possible, say let us say this is the L box length. So what are the possible wavelengths possible of the standing wave in this 1D box? Obviously you can see it is lambda by 2, so it is n lambda by 2 according to the nth states, and that must be equal to L. So lambda equal to 2L by n. This is the possible lambda values here. Now since this is a 1D box, and the electrons are non-interacting, so if electrons are non-interacting, the Coulombic potential or arising from the interaction between electrons, the potential electrostatic energy, the potential is 0 here. So the total energy that is being contributed in the standing wave is coming from only the kinetic energy of the electrons. That you all can agree, I guess. And kinetic energy of electrons, you can write it as p square by 2m, and since it is a standing de Broglie wave, you can write p as h by lambda. Do you all agree with me? I guess, I hope so. So it would be h square by 2m lambda square. Now you already have lambda from here. Substitute this to get total energy of the box, the energy of the system, or of an particular electron. This is for one electron, okay? I'm talking about only one electron now. This is only for one electron. So total energy of an electron in the nth state would basically result to be n square h square by 8 m l square, and I guess this is what has been given as alpha. So it is basically, we have n square alpha here. So E total, we have obtained a very important relation, is E for one electron is n square alpha, and since there are 4 electrons, so there would be like the same, the energy can be written in this form according to the state in which it is residing. Alright, so this is my energy expression. So now let us understand what is the ground state. First of all, what is the ground state? You can easily understand the ground. Okay, so let us, this is n equal to 0 and this is n equal to 1 state. Okay, so the ground state is basically a state in which it is occupying the four electrons in the minimum possible energy of whatever combinations of states it can be, because in only in one state there can only be 2 electron possible, because it is obeying the Pauli exclusion principle. So maximum of 2 electrons can only be possible there. So the minimum possible configuration would be like this, having the 4 electron. So this is my ground state. So don't confuse it with atomic a single monoelectron system, because it's not a monoelectron system. In a monoelectron system, single electron is there, so the ground state is just a single orbit, or the first excited state will be the next orbit to which it is excited. But here it would not be like that, because it's a molecular system where there are multi electrons, right? It's a multi-electronic atomic system. So the ground state is the minimum possible energy state, which is possible, minimum possible energy state that can be created out of the 4 electrons, and the energy corresponding to this is E naught, which can be easily written as 2 electron in the n equal to 0 state and 2 electron in the n equal to 1 state. So it is 0 square alpha plus 2 into 1 square alpha, and this is nothing but 2 alpha. So E is basically this is not n equal to 0. This is the first I have made a very big mistake. I'm sorry guys. This is not the n equal to 0 state, it is the n equal to 1 state, and this is the n equal to 2 state. Alright, it is not the 0 state, because the first state also has some energy. It's not 0 energy, because if I put 0 here, then my total energy would be 0. But this wave also has some energy, right? It can't be 0 energy. So this is n equal to 1. So when you actually do by quantum mechanics, you will see that the wave equations come out to be like this. I'm just writing it if anybody has any curiosity to know that. So the possible values for n is always 1, 2, 3 and so on, not 0. And this comes from boundary conditions. If you apply boundary conditions, you will know that n0 is not possible. So it's the state starts from n equal to 1 to n equal to 2. So I have made a mistake here. This is n equal to 2 and this is n equal to 1, the lowest possible states. So the lowest possible energy state is 1, corresponding to n equal to 1. So this is 1 square and this is 2 square. So the value is 2 alpha and 2 alpha plus, so the value of E naught is 10 alpha. So this is wrong. E naught is not 30 alpha. This is absolutely wrong. And now we have the energy of the highest occupied state is 16 alpha. Okay, before going to the highest occupied state, let us first do the other options, which is the energy of the first excited state and the second excited state. Okay, so now let us do for the first excited state. We know that excitation of an electron can always happen from the outermost shell, because that is possible, that is like electrostatically that is possible or favorable. Okay, so if I excite one electron from the second orbit, it happens like this and this. So this would correspond to my first excited state, which is n equal to 3, n equal to 2, n equal to 1. So the energy corresponding to the first excited state would basically be E1, which is 1 square alpha plus 2 square alpha plus 3 square alpha. Okay, so it will be 2 plus 4, 6 plus 9, it will be 15 alpha. So this is my first excited state, and it was given E naught plus 9 alpha. Is it E naught plus 9 alpha? No. So this is also wrong. It is not E naught plus 9 alpha. Okay. Now similarly, if I have to construct the second energy state, second excited state, I'm sorry, it would be something like this. And again, now just know that this is already unpaired. I can't shift this electron from here to pair it. That's not possible. That's electrostatically impossible. You cannot keep the lower orbitals unfilled and then go to the higher orbitals to fill it. That basically violates Auber principle and as well as Pauli exclusion principle. So what you cannot keep anything unfilled, so this electrons would be here. But what you can essentially do is you can actually, this is violated, so what you can do is you can excite this electron to this state. That's possible. So my second excited state would be something like this: n equal to 1, n equal to 2, n equal to 3. So it would be E2, which is my 1 square alpha plus 2 into 2 square alpha plus 3 square alpha, and it would come alpha 1 plus 8 plus 9, which is basically 18 alpha. And this is, okay, this one was E0 plus 5 alpha, and we can see this is E0 plus 8 alpha, right? Because E0 was 10 alpha, this is E0 plus 8 alpha, so E2 is E0 plus 8 alpha. So this option is correct, this is E0 plus 8 alpha, so this is right. So let us check for the second option, because that the concept would be clear what we are doing. So what can be the highest occupied state? Let us think from the second excited state that we have already achieved. So I can't excite this electron, alright. I cannot excite this electron by keeping the third state empty. So what I can do, I can actually excite this electron to the third orbital, right? And then it would come here, am I right? And then what I can do, this would become my third excited state, and then what I can do is I can again excite this electron into a step above, which is in my n equal to 4 state. So that would be my fourth excited state. So basically the highest possible state is my fourth excited state. The highest excited state is my fourth excited state. And how it came, the explanation I just already gave now from here. So let me just draw the state for you guys. It would be something like this. Sorry, just trying to one. Yeah, and the energy cost corresponding to this, so this is 4, this is 3, this is 2, this is 1. The energy corresponding to this, I say highest occupied orbital, so I can say highest occupied molecular atomic orbital or molecular orbital, whatever you like to say it. Highest occupied orbital, I would say highest occupied. So this would be 1 square plus 2 square plus 3 square plus 4 square, right? Times alpha. So this is 1 plus 4 5 plus 9 14 plus 16, which is 30 alpha. So the highest occupied orbital has 30 alpha energy, which is E0 plus 20 alpha. So the second option is also wrong. It should have been 30 alpha, which is this is the HOMO, highest occupied molecular orbital. So the correct answer for this question is option D. So we are done with the first section, which is the single correct answer type question. Next we will solve and move into the second section, which is the multi correct answer type question. So let's meet in the next video. Thank you.